Welcome to the SPSS tutorial video on the generalized linear model. The generalized linear model is an expansion of the general linear model, which is often referred to as regression. It uses different types of outcome variables. In this video, we'll be covering logistic regression, which is a regression under the generalized linear model using a binary or a yes-no type of outcome variable. We'll also discuss options for how to run Poisson distributions and other types of options within the generalized linear model. For this video, we'll be using the therapy dataset used in previous videos. However, I've created a new variable, the final one listed here, called depression at time 2 high-low. For this variable, as you can see under the values, I've created a new variable such that all the scores for depression at time 2 that are below the mean were now coded as 0 or a low depression group. I've next coded all the scores that were above the mean under a high depression group scored as 1. We'll be using this binary outcome variable for our logistic regression. To run a logistic regression, you can do it in multiple ways, but what we'll be covering today is the generalized linear model. The first page you see under these tabs at the top of the screen within the generalized linear model is the type of model we'll be running. Here, if we specify a linear scale, it's just like running a typical regression. We can also run generalized linear models with ordinal responses, that is, responses that are categorical but in certain orders, count variables, such as the number of behaviors a person shows in a study, or in this case, a binary variable, a binary logistic variable for logistic regression. We next need to indicate which is our outcome variable. Our dependent variable, as I said before, is depression at time 2 scored high and low. And for any binary variable, SPSS is going to ask you to specify a reference category. You can choose either the highest value, the 1 in this case because we're coded 0, 1, or the lowest value, which of course would be 0. The only thing this will change in the model is the sign, the positive negatives of the coefficients within the model. Other than that, the math is the same. After we specify our dependent variable as well as the reference category, we need to add predictors to our model. Unlike the regression menus, the generalized linear model splits predictors into two types. It includes factors, or categorical predictors, and covariates, or continuous predictors. For the sake of this example, I'll add one of each. Let's add participant sex as our factor, as our categorical predictor, and optimism as our covariate. Now we also need to include which variables will be included in the model. We need to specify that both female and optimism will be included into our model. We can also choose, under this building terms, whether we want only the main effects included in the model or whether we also want to include the interaction between these two terms. For the sake of this example, I'll choose the interaction. Now the other tabs seen above, estimation, statistics, estimated marginal means, save, and export, provide a great deal of more sophisticated options for how to run specific models within maximum likelihood, for how to output specific types of statistics. But for most users, what I've shown so far within these first 4 tabs will be sufficient, and we'll run this analysis. As with most output in SPSS, it first reminds you of what you ran. Our dependent variable was depression at time 2 with high and low. We chose a binomial distribution and a logit link function. This is for logistic regression. Again, your instructor will discuss other link functions and probability distributions such as Poisson distributions in class for you. We're reminded of how many cases are included. We have 150 people. And under our categorical information, it includes how many of our dependent variables were listed as high and low. We had 77 people who were in high depression and 73 who were low in depression. Next, we see the descriptive statistics for our continuous variable of optimism. Beneath this table, we see a table for goodness of fit. This is the chi-square goodness of fit values that we see used in the omnibus test below for the likelihood chi-square ratio. This omnibus test is whether we find out whether the overall model is statistically different from 0. Below the tests of the overall model, we see specific tests for each of the variables We can see here that female, or our sex variable, was not a significant predictor of depression, categorized as high or low. Our optimism variable was a marginally significant predictor with p less than 0.10, but not significant at p less than 0.05. We also get parameter estimates that looks much like a regression table for our individual predictors. Now, we've completed a logistic regression, and I'll show you briefly how to run a Poisson regression, although we won't run the actual output. We'll return to Analyze and the Generalized Linear Model. For our type of model, instead of specifying a binary logistic, we'll choose a Poisson distribution.